Good morning and welcome to the next part of my Practice SAC walkthrough, walkthrough 1. This is part 2, so this is obviously for question 2. Following along from the gas conversion, we've got a different gas conversion company who has an alternative offer. They suggest that they will let him pay off the conversion at $40 a week until he has paid off the full amount owed after all the rebates and all that other sort of stuff. Under this deal, it will cost him $640. The driver of the car that's being offered this deal works out that after the gas conversion, he will have about $25 a week for gas. So, question 1 asks, what would the owner have paid in total for 8 weeks of both the gas and the conversion? So, that's 8 lots of 40 plus 8 lots of 25. So 8 lots of 40 is 320, 8 lots of 25 is 200, therefore it would have cost him $520. How many weeks will it take the owner to pay off his conversion? All right, so right now we don't care about the $25. The $25 is not important for this question. How many weeks would it take the owner to pay off his conversion? Well, let's have a look. The total cost of the conversion, I'm going to do some red underlines here because I want to make it obvious. And then there's the $40 per week. So we need to do 640 divided by 40, and that will tell us how many weeks it's going to cost. All right? And that happens to be 16 weeks. What would it cost the owner for the conversion and gas usage in total 30 weeks after the conversion? So you have to take this problem and you have to split it into two. One is how much will it cost for the conversion and how much will it cost for the gas? Because remember, he is not paying all that time, all 30 weeks for the conversion, but he is spending all 30 weeks paying the gas. So what would it cost the owner for the conversion? So first things first, it's going to be the $640 for the 16 weeks of $40. Then it is going to be 30 times the cost of the petrol, which is the $25. So that is going to be 640 plus 750, which is $1,390. All right, the next part is we have to graph the relationship between the total cost and time in weeks on the graph. So to help us plot it out, what we're going to do is, first things first, we're going to remember that this graph is obviously going to start at 0, 0, because if no time has passed, he hasn't paid anything. What we also need to remember is we've actually already worked out another piece of information. We have, up above there, after 30 weeks, he paid $1,390. So we're going to go to 30 weeks. We're going to go just a smidge under the 1,400 dot. And we're going to put in there 30, $1,390. Just to help us remind ourselves. Now, what we need to remember is that because the situation around the money changes, you are going to have two different lines. All right, so it's going to be two different lines that will change. The angle or the gradient of those lines will change. The slope will change. And it's actually going to change after the 16 weeks have passed, because after 16 weeks, he no longer has to keep giving the company the $40 for the conversion. So to help us plan things out, what we want to do is we want to try and find the value of the 16 in here. So to do that, we're going to go to our calculator. So after 16 weeks, he's paid $640. We already get that. Then we have to think, well, okay, if he's done 16 weeks of paying off the conversion to pay it all off, how much has he actually paid in fuel this entire time? So we can also do that by doing 16 times 25, and we get 1,040. So again, 16, there's 1,000, halfway to 1,000, 1,100 is that, so we're going to go a little bit below that. And then we're going to make a mark here, and that's obviously going to be 16, 1,040. So now we have two distinct parts of time. All right. One represents the 16 weeks where he's paying off both the gas conversion and the money to put the gas in the tank. And then after 16 weeks is the rest of the time when he's just worrying about the gasoline. So let's finish by putting some lines in. So we're going to have two lines. One is going to go from 0 to 16. And we'll make this make it nice and thick so you can see it. And then we're going to get a second line. That's going to go the rest of the way from 16 to 30. And we'll make that line also nice and thick. So you can see there on the graph that the slope changes because the amount of money he has to keep spending decreases. So that means the gradient has changed again. So we've got our 0, 0 because obviously no time has passed. We've got our point where the price and the money going in and out changes. And then we have the final point at the end of the 30 weeks. So remember, this type of graph can be described as a piecewise graph. All right, so it's one set of equations that describes one situation. Now, write two equations, including the appropriate regions that fully describe the relationship between C and T. So, here's what we have to remember, is that the green line is going to have a different equation to the blue line. And we're going to have regions. So these are going to be values of T, or time. So between 0 and 16 is going to be one set of information, and between 16 and 30 is going to be a different set of information. So we're going to have two regions. We're going to go 0 is less than or equal to T, which is less than or equal to 16. And then we're going to have a second one where it is 16 is less than T, but is less than or equal to 30. You can put a double greater than or equal to in there, but it might get it confused. But at 16, they're going to be the same anyway, so no matter. So we've got our regions defined. Now, if you think about it, that green line, if he's paying $40 a week for the conversion and $25 a week for the gasoline, how much is he paying per week in total? 40 plus 25 is 65. So, C is going to be equal to 65T in the first 16 weeks. But after that, what's he got? Now, if you were to keep taking that line and you were to keep tracing it back and back and back, you're going to get a y-intercept, this blue line. To write the equation for the blue line, we need to think about where that intercept would be. Now remember, it's $25 a week for fuel. So if we go all the way back to zero, how much money do we have to then think about? Well, we only have to think about the cost of the gas conversion. All right. So that means that if we know what the cost the cost of the gasoline is each week, we can just substitute in the cost of the conversion. Now remember that 640 helps get the graph up to where it needs to be, because if we didn't put that in there, then the line would start all the way down here and go somewhere else, and it wouldn't look correct. So we have to move it up to where it is, where it should be. And in both of these cases, 65 times 16 and 25 times 16 plus 640, they overlap there. So that is your piecewise equation to represent what C is. So it's two distinct lines creating a piecewise graph where that is the situation. And the cool thing is that you can indeed put this into your CAS. So we go into our CAS under keyboard. If we go down to Math 3, we want to go to the third row, fourth column. We want to press a button that looks something like this, and it gets us a bunch of boxes, and we can start typing in our equations. And while we're also on Math 3, that also helps us get our inequality symbols to help us draw this properly. So 25x plus 640, well, that's between 16x and 30. And then when I draw it, well, obviously I'm not going to be able to see anything because everything is, the window's not set. So we're going to go in and we're going to change this to 0 to 34. Scale of 1, that's fine. Y minimum 0, Y maximum, we'll set it to 1500. Scale of 100. And you can see there the line goes up, takes a sharp turn, and then keeps going. And when I trace over it, because it's a piecewise graph, it just is one continuous line. And that is how you do question 2.